welcome to today's webinar on APIs, the gateway to digital transformation. My name is Nuwan Dias and I'll be presenting to you today on this webinar. I work as an architect at WS2 and my main area of focus is on the WS2 API Manager, API Management Platform basically. So let's begin the webinar, and thanks again to all of you who are joining us from various parts in the world. This is a rough agenda for today's webinar. We'll be talking about what digital transformation is about, and we'll then look into why and how APIs play a critical role in digital transformation. We'll then look into the key performance factors of an API ecosystem when dealing with a digital transformation journey basically. We'll go into details of each of those factors when we are talking about each one of them, and then we'll go into the various kinds of deployment options you have in the API ecosystem to set up a platform for transforming your business digitally. And we'll also look into the roadmap of the WS2 API Management Platform on the things to come ahead, which can support you as a business transforming your business digitally. So let's move into the content of the webinar. So when it comes to digital transformation is not a fancy thing. As a business, a digital transformation really means all about the experience that you deliver as a business to your customers. That is basically the fundamental of digital transformation, the digital experience that you provide. So some recent examples that are happening around the world are, so you must have heard about Amazon Go, where Amazon came up with this cool idea to open up a supermarket basically without any employees, and you just walk into the supermarket and you just grab the stuff that you want with your mobile device in hand, and you walk out of it, and all your payments happen automatically, and there are no queues, no cashiers. You just grab the stuff and walk out. So that is one clear, clean example of the kind of digital experience that Amazon has provided when you compare with traditional supermarkets that we have out there today. Another similar experience is if you've been to Starbucks in the US. So Starbucks, for busy customers, busy employees, customers, they have something called on no time, no line. So basically what that means is you could order your Starbucks, your coffee, while you're going into Starbucks and just grab it and walk out once you're there. So you don't have to usually go through the long queues and wait for the barista to take your order. You just go in and grab your coffee and walk out. So this type of digital experience is basically what transforming a business digitally means. So it's not just about becoming paperless. So there's a misconception that you becoming paperless is digital transformation. So becoming paperless in the modern world is kind of old school. It is true that still there are some businesses that do require a lot of paperwork, and getting those in computer systems and software related systems is not really digital transformation. It's about giving a novel and a personalized experience that what calculates as digital transformation. So it's also about a connected experience, in the sense that, so what you see on the screen is basically a particular website that helps you to make train bookings in the Europe from traveling from one place to the other. And if you notice right down there, down below, you have an option to search for accommodation while you are searching for trains to travel. So how this basically works is, because this particular website, by the time you're done searching with your trains, it talks to the Airbnb's APIs that help you to search for accommodation, and when you get the results for your train tickets, it also gives you options to search for some places to stay in the particular place you are traveling to. So since this site knows the dates that you will be traveling on and the dates that you will be returning on, it can easily provide this as an input to the Airbnb's APIs as well and find you accommodation in this particular place. So now you don't have to worry about going in and searching for accommodation too, because this site basically does that for you as well. So this connectedness, this connected experience is one particular example of the digital transformation. And if you think about how this has been achieved, what is powering this digital experience is basically the APIs that are exposed by Airbnb in this particular case. So Uber is also another fantastic example of giving a digital experience. So Uber is being talked about by many people and taken up by many examples. So it is when you compare it with traditional taxi systems, it gives you a personalized experience where you just have to walk out from where you want to travel and you just take out your mobile device from your pocket and book a taxi and it will be there in a few minutes. So it's like having a personal driver who is just a touch away from where you are. And another important thing is in Uber, when it comes to costs. So unlike traditional taxi systems, Uber gives you an indication of how much it is going to cost you to travel for your commute basically. So that is really a valuable experience when you compare it with traditional taxi systems, and that is why basically Uber has now become the world's largest taxi operating system company basically, but they do not own a single car basically, but they are the world's largest taxi system. And what has really fueled this growth in Uber and this popularity is simply the experience that they give, and what has fueled that experience are the APIs and the technology that is backing those particular APIs. So another beautiful thing about APIs operating in the providing a digital experience is that APIs are also used to complement each other. For example, in this particular screen, what you're seeing on your screen, Google Maps actually uses Uber's APIs to provide you a cost estimate of your route, basically, of your commute. And Uber, on the other hand, uses Google Maps APIs to give you the cost of your travel and to get you the routes of your travel as well. So this is one beautiful thing of using APIs as well, where Google Maps uses Uber's APIs and Uber uses Google Maps APIs, and they complement each other in providing a digital experience. So what is really pumping or fueling this digital experience is really the APIs that are backing up these systems. The fact that Uber exposes its APIs to be consumed by other third parties is really giving out value for Uber and for other businesses as well. So when you look at it from an outside view, you will notice that on the receiving end of this digital experience are the people, the human beings who are us. And we being on the receiving end of this experience, we use our applications, which represents a digital double of us to consume these APIs that are offering these services. So the devices that we use on a day-to-day basis are smartwatches, our mobile phones, our tablets, our cars, our smart homes. All of these devices and applications within these devices, they consume APIs for giving us this particular digital experience. And the APIs, on the other hand, consume services and data offered by different types of organizations to give us this particular experience. So this is basically what happens behind the scenes, and these are the components that fall into picture to provide us human beings with this really magnificent digital experience. So when as a business, as an organization, when considering of exposing these valuable services and data that you offer out as APIs, there are some key things that you need to consider before doing that. So far you have been having these services that were consumed by your own consumers who were under your control using your own policies. So now when you're getting this out into the open world, there are a set of things that you need to think of and understand before doing that. The first one of them being security. So obviously all this time, all this data and services were under your control, and when they are going out into the world, security is the primary and main factor to think of in the first place. We'll talk detailed in security as we go along. And the second factor is rate limiting. So yes, it's important that you understand who is accessing your services, under which privileges, but it is also important to understand how much of your services they are consuming. Because when you expose your services out into the open, what happens basically is that you will be getting a lot of exposure into your services that you didn't have before. Therefore, your services will now be consumed a lot more than they usually were capable of, and therefore it is important to understand and limit how much of your services you are exposing to the outside. And integration again is a very critical and an important factor. So if you step back and think of why you are really doing this, why you are really exposing your services as APIs, you will remember that the reason that you are doing this is for innovation. So you are doing that so that third parties or your own developers or other people can come up with innovative ideas to consume your services beautifully. So what that basically means is that you may be exposing your services as they are today, but if they are to give you a real value in the future, they as they are won't be of a lot of value. So you will need to integrate certain services with certain other services or with certain other systems in order to expand your level of innovation on these services. Therefore, integration is another key factor to think about when you are exposing these services and data to the outside world. And finally, we come into another important thing, which is analytics. So analytics again plays a very critical role because it basically helps you to understand how your business is running. It gives you insights into how your services are being consumed, by whom, from where, at which time. So that information helps you to make business decisions for the future, and it also gives you insight as to how your business is running today. And another important fact is operational analytics, which we will also dive into when we talk in detail about analytics. So let's take up these key performance factors and see how they come into picture when setting up an API ecosystem. So these key performance factors, security, rate limiting, analytics, are of course things that we could technically build into our services and into our core APIs. But building it into those services is a bad idea. Reason being that you would be mixing and matching two unrelated concepts, and when you do that, basically you will have scalability problems and you will also have maintenance problems as well. Therefore, that is the reason it's a good idea to always have an API gateway and delegate all these factors such as the security, rate limiting, analytics, and integration to a separate API gateway layer and have your services and data do what they do best. So an API gateway in an API ecosystem would come in as a proxy, intercepting all the requests that go in through these applications into your system and performing these layers of security, rate limiting, integration, and analytics. That's how the API gateway becomes a critical part in the API ecosystem. So we'll talk about security in detail next. So when it comes to security, the primary fact is identity. Who is accessing my services? So authentication is an important factor to identify that. So for the people who are accessing your services, you first need to know who is authenticating, who is the person that is using this service. So your API ecosystem needs to have a way of accepting a user's credentials in whatever form and checking whether that user is a valid user or not. And there are also instances where the users within your organization or within your enterprise would already be logged into other systems, and they would need to consume services exposed by your API ecosystem. So since they are already logged into other systems, it would not be very nice, not be a very good user experience if we would ask them again to log in to access our services. So therefore, we would need a mechanism to automatically log them into our services, our APIs, if they are already logged in to another system. So the single sign-on capabilities in the API ecosystem are important so that we could handle this situation of when they're logged into another system to automatically get access and grants to our APIs. And federation is becoming an absolutely critical and an important factor in modern applications. So you may notice lots of instances, lots of applications where the applications allow you to log in using your social credentials, like Facebook, like Google, and Yahoo, etc. So in the modern world, your social identity is becoming your identity. So the image that you see on the slide here is where Airbnb allows you to log in or use its APIs by logging into Facebook. So you log in into your Facebook, and Airbnb can identify you as a user who has a valid Facebook account, and he knows who is accessing his services when you basically log into Facebook via Airbnb's APIs. So federation is an important factor. So in this case, what basically happens is Airbnb has the capability of federating with Facebook and logging you in and granting you access to the particular services on Airbnb. So it's important that your API ecosystem has the capability to federate with these types of third-party identity systems so that they could log you in, log your users in through those systems and grant you access to the APIs in your API ecosystem. Finally, authorization plays a very critical factor too. So just because you are a valid user, it doesn't mean that you get access to all of the services and all of the resources in the system. Your access is determined by the level of permissions and privileges that you have. So you may be a valid user, but you may have access to only a subset of services, whereas you may not have access to another set of services because of your privileges. And it could even go finer grained than that, such as you could have policies which say only allow access to a particular service if a user is in a particular privilege, plus if this user is accessing this service from Monday to Friday between 8 a.m. to 5 p.m. So this amount of fine-grained access policies should ideally be catered by your API ecosystem as well, because these are real-world requirements that come in when you move along this journey of digital transformation. Then, if you remember the image that I showed in the beginning, so we as human beings, in order to get this digital experience, we always use some kind of an application. So it is this application that may be on our watch, that may be on our mobile, that is accessing this particular service on behalf of us as humans. So what we are basically or practically doing is granting our access or delegating our access, our rights to an application to access a set of services on our behalf. That is what we are doing practically. So this is called access delegation. And when it comes to delegating our access, there are several factors to think about, because we use different types of applications, and these different types of applications have different capabilities and capacities. Therefore, security is important to consider in each of these instances, and there is no single way of handling security for all of these instances. Each instance needs a dedicated scenario or a dedicated way of granting you access. So some types of clients there are secure trusted clients. So one example of this is, like, if Facebook itself is developing a mobile application to access Facebook's APIs itself, That means Facebook trusts its mobile application because it is its own services or APIs that this particular application will be accessing. So in this case, the API provider, Facebook, trusts his own mobile application, and in this case, these types of clients are called secure, trusted clients, and handling security in those cases is fairly straightforward. And then there are secure, untrusted clients. So this means that the client application that is accessing your service is secure. For example, it could be a web application. So a web application usually runs on a web server, and a web server is considered as a secure server because you can control who accesses the web server, who configures the web server, who sees the files in the web server, such as that. Therefore, a web application can be considered as a secure application, but if this web application is developed by a third party whom you do not trust, you may not trust that particular application to accept your user's credentials, because you do not know whether that application will steal your user's credentials. So in those kinds of scenarios, handling security needs to be given further thought, right? So your API ecosystem should have the capabilities of handling security in each of these different scenarios. And then there are unsecure clients. So unsecure clients are the type of clients like JavaScript applications that run on users' web browsers. So single page applications that are very common today are a good example for this. So they run on JavaScript on users' web browsers, and therefore they are not secure, because when it runs on a web browser, anyone can basically see what data it holds and even modify some of the data that it carries. So if a particular SPA or JavaScript application needs to access a set of APIs for performing some kind of functionality, how this application is granted access into these services needs to be given a lot more thought than the other two clients. So there are standard ways of handling each of these scenarios, and even customized ways of handling them too. So when you are setting up your API system, it is important to consider these facts and validate that your ecosystem is capable of handling these scenarios that you're interested in. The final one is system-to-system authentication and authorization. So when it comes to system-to-system authentication, there is no human being involved. Therefore, there is no such thing as a username and a password. So how trust is established in these scenarios is usually by using certificates and signatures. So one system presents a signature to your API ecosystem, and your API ecosystem should now be able to validate this particular signature and ensure that this request is coming from a trusted system, and therefore grant access to this particular system based on the rights it has. So these are some of the key security factors to think about when exposing your services as APIs to the outside world. Then we move on into rate limiting. Going beyond security, just because a user is valid and has rights to access your services doesn't mean the particular user should get an unlimited quota of services, of access basically. So different consumers use rate limiting in different forms. So one is for monetization. So in this slide, we are basically talking about rate limiting on the front end. The front end basically means the layer between your user and the API gateway. This does not include the layer between your gateway and the backend system. We'll talk about it in the next slide. So the services that are on your gateway are consumed by applications belonging to different users. So a particular service, when a particular application developer requests to access particular service or API, this API would give that particular application different quotas to choose from. So these quotas could be used in the form of gaining some monetary value from that particular application. So if the application developer pays more, he can get a larger quota. If the application developer pays less, he would get a lesser quota. So this rate limiting can be used in that form. And also, just because an application has a quota, let's say 10,000 requests per week, that does not mean that quota can be consumed within the very first minute itself. The system should ensure that this quota has a fair distribution across that entire week. Therefore, it is important that the API ecosystem can perform burst control to avoid that particular application consuming its full quota within the very first minute or so. So therefore, then again, your application would have several users, could have many users. So if you do not ensure a fair usage policy, one given user could potentially eat up all of the quota that belongs to the application, and if that happens, the other users of this particular application would starve. So to avoid that fact, your API ecosystem should have the capacity to ensure fair usage policy by user. So therefore, a given user will only be allowed to consume a fraction of the quota of the application and not the whole quota of the particular application. Rate limiting can also be used geographically. So it could be regionally distributed, or it could even be like internal, external distributed. For example, if you have a particular service that is consumed by your internal employees and also by the public through the internet, you could have a policy on the gateway which says allow a high quota for my internal consumers and allow a lower quota for my external consumers. So the API gateway or the API proxy should have the capability in doing this, because these could be real requirements that come in when you walk through the journey of transforming your business digitally through APIs. Another interesting and important fact is distribution by device type. So you could have a set of services which are consumed by web applications, by mobile applications, and by other types of clients as well. So you could set up a distribution by device type by saying, if it's for mobile applications, allow a larger limit, and if it's for web applications, allow a smaller limit. So these are again some of the use cases that would come in and that you would be forced to think about when setting up your API ecosystem. We then move on into rate limiting at the back end. So this is again critically important, because all this time your services were consumed by a known set of people on known days on known limits. But now when you expose it out into the public, there is a potential that your services could get hit a lot more than you anticipated. So if you know the limit your backend services can handle, you could set up that limit at the gateway to tell the gateway, do not allow more than this number of requests passing through the gateway into my backend system. What we have seen sometimes is that when it happens, there's a huge peak coming in at a particular time, and that basically causes the services to go into a full outage. But if you have the capacity in your API gateway to limit it to a particular known limit, then only the consumers who are going beyond that quota would experience an outage, because the gateway would cut them off. The rest of the consumer would still get the normal consumption, and therefore you don't go for a complete outage, but you only block out the people who are going beyond the particular quota, and therefore you have your system up and running for a long time. Then a very important thing comes in integration. So when it comes to APIs, I explained why integration is important in the very beginning. So an API is basically the front-facing interface that is to the outside. What happens inside could be extremely complicated, and it could change from time to time. For example, in this particular circuit board, these analog connectors are the interface that connect to different outside systems, and inside you have a whole lot of integration that do a lot of complicated things in order to transform this signal into a digital signal. So this is exactly what happens in the world of APIs. You have a clean set of interfaces exposed, and inside you do a lot of innovation, a lot of integration in order to give better experience to your consumers. So it is important that you have a clear differentiator between these two layers, so that you can change your integration but make your interface remain the same. So in the modern world, microservices are getting a lot of hype and a lot of interest, and many people are rewriting and their services based on microservices. And in the microservices architecture, the API gateway plays a very critical role, because all the security, the rate limiting facts are taken up by the API gateway, and the rest of the business logic is taken up by the microservices. So you may be setting up your microservices today in order to meet your current business needs, but 2 years down the line, your business needs would definitely change. So when that happens, what do? Do you rewrite your microservices or bring in new microservices to adhere these requirements, or do you handle it at the API gateway? So both of these approaches are followed, but usually changing existing microservices is not recommended. But so a usual practice that happens is that the integration that is required to cater these new business needs are done at the API gateway itself. So you get the API gateway. If you want to meet a particular new business need, you get the API gateway to integrate between several available microservices or even new microservices and cater your new business need. So in order to do this, the API gateway needs to have the capacity and capability of doing integration. However, the current API gateways out there in the market have a huge problem when it comes to integration, because they are primarily designed as a pass-through proxy, which only focus on security rate limiting and other meta aspects, and not really integration. So as Mike Roberts has identified in his article on serverless architectures, which is on martinfowler.com, he says that API gateways, the integration factor on API gateways is achingly immature, mainly due to the fact that it lacks the tooling that it needs to perform the integration at the gateway. So we have at WSO2 have taken this up pretty seriously, and as a solution to this, we have come up with an entirely brand new programming language dedicated for doing integration. So this programming language is called Ballerina, and you can find details on it of it on ballerinalang.org. The idea is to get this integration capabilities on the API gateway layer. So when you have needs of performing integration at the gateway, you can basically use this particular integration language and get it done. The API gateway usually operates as a proxy, but if you need it to do integration, you can use the capabilities of Ballerina to get it done. The beautiful thing about Ballerina is that it operates basically on a sequence diagram mechanism. So the current tooling that you may have seen for integration so far work on data flow diagrams. So data flow diagrams are good for doing integration, but when it comes to doing real parallel execution, mainly on systems like microservices architecture, data flow diagrams really don't meet that need. But sequence diagrams are a really great way of illustrating that particular integration. So basically, as an API developer, what you would do if you need this kind of an integration is that you would bring up the API tooling and draw this particular sequence diagram that represents the integration that you want to do. So in this particular example, you have one service and two resources in the particular service. So this service is also an API, and upon receival of a particular request, the first resource, it talks to two external connectors. So these connectors are basically third-party systems which perform different functionality, and it gets the responses from both these systems and gives an aggregated response back to the calling client. So it's a simple use case, but a very valuable one too. And the beautiful thing is, you could draw, as an API developer, you could just draw this diagram, and the gateway would do the integration for you. And when you draw this diagram, basically the tool itself converts this diagram into a textual representation, and this is the textual representation that you see, not the exact one, but a similar sample. And this particular code runs on the gateway and performs the integration that is required by your service. Then we move on into analytics. So like I said, analytics plays a very critical role in the form of statistical analytics and operational analytics. So when it comes to statistical analytics, this is the type of analytics that helps you understand how your business is running. For example, it gives you details of where your APIs are being consumed from, which region in the world is consuming my APIs the most. So this might help you to make decisions on where to set up your infrastructure next, and it gives you an idea of who is most interested in your APIs, which part of the world, and helps you to make business decisions. Also, it gives you an idea of like what your API consumption is, how many requests am I getting hit from which applications, and who are the top users of my API. What are the limits that are being hit? Are people going beyond quota, or are they generally staying within the limits? So likewise, there's lots of valuable statistical analytics that is provided by the tool that helps you to make business decisions, basically. And it also gives you a very clear picture of how the current system is running, of how the current business is running, because it gives you insights to the consumption of your services, and that gives you a very clear picture of the current situation of the business. Also, it gives you operational analytics. So, for example, it gives you an understanding of the performance of your API. So, an API, like I said, performs different things such as security, as rate limiting, and accessing your core service. Likewise, so it gives you a breakdown of what is the time taken for each of these. What is the time taken for the security? What is the time taken by the core service? What is the time taken for the rate limiting and analytics, and those kinds of things. So that gives you an operational view of what is going on inside your system and how your APIs are behaving. And another very interesting and important thing is detecting abnormalities. So your system should have the capabilities of understanding the usual patterns and alerting the relevant people on abnormalities. For example, if a particular token that was being used by a particular user was being used from the United States, and within the next hour, if that same token is being used from Europe, that probably means that token has been stolen by someone, and that is why it is suddenly being used from an unseen IP address. So detecting these kinds of abnormalities and firing alerts is a critical factor in your API ecosystems, and the criticality rises depending on your industry. For example, if you're in the financial or banking industry, these kinds of abnormality detection and firing alerts is a critical factor. So the WSO2 API Manager, for example, it provides a whole set of abnormality detection, such as the one I mentioned before. So it can detect lots of abnormalities and fire up alerts when they are to the relevant folks. And API health is also an important factor to see and to identify the health of your APIs. Are they firing errors, or are they going on successfully? The response time, is it degrading, or is it keeping up on average? Likewise, so the health of the APIs are also important. So these kinds of operational insights are also important when you're running an API ecosystem, because this is now important to your business, especially if it is generating revenue, and also for service uptime and various other factors. And when considering an API ecosystem, there are different deployment options to choose from. The first is on-premise. So when you set up your ecosystem on-premise, you basically have full control of your system, and it gives you a better performance because everything is internal. You don't have to make it go through your firewalls and all. The interaction between the various components all happen internally, therefore it is fast. However, it is limited to your infrastructure that is available to you within your enterprise, and you basically need to handle the upgrades and the updates on your own when you have an on-premise deployment. So it has both pros and cons. And then we have the cloud option, where the API ecosystem is basically set up on the cloud. So all your APIs are on the gateway, which is in the cloud, probably consuming other cloud services. So your applications would be consuming your APIs basically on the internet. And so the cloud infrastructure, you could basically leverage the cloud infrastructure and don't have to be limited to your enterprise infrastructure. And it doesn't involve any maintenance costs as well, because the upgrades and the updates will be taken up by the folks who are running the cloud system. And then there's also a very popular deployment pattern that is coming up. Basically, this is known as the hybrid cloud. So in this case, the gateway component sits on the cloud, on the internet basically, but the security layer, the authorization server, sits internally. So when a request comes from an application to the gateway basically comes back home to validate whether this user is a valid user or not. And after validation, it basically puts that user in a cache on the gateway so that it can prevent coming back home always. And in this particular case, the gateway can consume both cloud services and internal services as well, because this is set up in a hybrid cloud deployment pattern. Therefore, it has access to in-home services as well. So coming to the final point on the roadmap for the WSO2 API manager. So one of the key things that we are looking at in the future is to make the API gateway component, the API manager basically, much container friendly with much less CPU and memory footprint. So we are basically looking at a gateway that can do micro integrations. So what that basically means is that you could have one gateway per service, and you could scale out that particular gateway independently without having to scale up the other gateways. So the earlier model was such that the gateway was a monolithic component, where the gateway basically hosted all of the available APIs. But now we are looking into a pattern where we could have this concept called micro gateways. So you could technically have one gateway per API if you wanted, but it also supports the monolithic gateway model as well, where you could get all your services exposed on a single gateway too. Nevertheless, in terms of performance and boot up time, we are looking at less than 5 seconds, 4 seconds boot up time with extremely low memory and CPU footprint to make these components container friendly, so that they could scale up very fast. And also, we are now taking up API proxy development pretty seriously, mainly to address the integration needs coming in from the microservices kind of architectures, because when moving on into microservices architectures, the responsibilities on the API gateway are becoming more and more, because it is now no longer a simple proxy, but bundled with a few more responsibilities to handle too. Therefore, the tooling is we are developing basically a new tooling for developing APIs, which includes the Ballerina editor that I showed to you, so that they could write, the API developers could write their integration, and it comes with testing inbuilt, and also to have collaboration capabilities possible. So what we've learned is that API development is not a single person thing. It is like a normal software development process. Therefore, there needs to be collaboration enabled between several developers. You need to basically have the capability to commit your API interface to a GitHub repo, get your fellow contributors to look at it and make modifications, and then finally get it, run it through a CI/CD process, and get it deployed on your server. So it's basically the development of an API is now almost exactly the same as developing any other piece of software. And what that basically means is that we need stages for the API development too. So all this time, we more or less had stages for developing backend systems, because those were the ones that went through changes in terms of source code, in terms of design changes and all. All this time, the API was more or less a proxy, but now more and more we are seeing a lot more things being done on the proxy than just being a simple pass-through. Therefore, it is important that the API proxies go through these stages as well. So the product basically will have knowledge of these different kinds of stages and have the capability to move artifacts between these different kinds of stages, and have like one user experience to log into these different stages and move artifacts across stages, just like you would do in setting up any other software system. So, however, there's a DevOps fact that comes into play as well, where the scripting capabilities are supported, and then there's a command line tool that is available, so that the DevOps could use this particular tool in order to move artifacts from one environment to the other and have them deployed through Jenkins jobs and similar tools. When it comes to multi-tenancy, so far the current version of the product had a single runtime and a single data storage, which was shared across different tenants. So each tenant got a logical isolation of the runtime and the data. It wasn't a physical isolation, but to support the upcoming needs of multi-tenancy and to have the capabilities of extreme scalability and gaining the advantages that we get from container systems like Docker, we are looking at building the system in such a way that each tenant gets a physical runtime and a physical data storage. So what that basically means is that each tenant would get its own runtime and own database, instead of having one database and with logical isolations. So these are some of the changes that are happening in the product, and these are some of the key things that we are looking at in the upcoming versions. So in conclusion, that brings me to the conclusion of this webinar. So digital transformation is a journey. It's not a simple task, and APIs play a very critical part in it. So the WSO2, in WSO2 we focus on 5 main areas which we believe as the core ingredients of building a digital experience, of helping you as consumers, as customers, to build your digital transformation. So this webinar is one of the series of these webinars that we conduct on digital transformation. So we have already concluded the webinars on integration, identity, and IoT, Internet of Things, and there's smart analytics webinar coming up next week. So please do join that, and we will be talking about how you could use smart analytics as a way of helping you to transform your business digitally. So that brings me to the conclusion of the webinar. I hope it had been important and given you lots of thoughts to think about. If you have posted any questions, I would be happy to take them and answer as much as possible. So there is one question asked, what is your recommendation on SOAP API? If the API exposed as SOAP, any documentation recommendations? So when it comes to SOAP APIs, what you should first consider is, are you exposing them as SOAP services, or are you converting them to REST services? So SOAP, in the common world, SOAP is slowly going away and being replaced by REST. The conversion is not as fast as we thought, but it is definitely happening. Therefore, the first decision you have to make is whether it is first, whether you want to expose it as source or SOAP or convert it into REST. So if you are exposing it as SOAP itself, basically then the gateway can act as a simple proxy to your existing backend system. But if you want to expose it as REST, then you need to do some conversion or transformation on the gateway so that you could expose a REST interface to a SOAP backend system. So you could basically do that using the already available tools. You first need to decide on the REST interface that you want to expose, come up with the Swagger definition for that particular RESTful API, and create that particular API on the gateway, and do some mediation and transformation basically at the gateway to convert your JSON into a SOAP that goes out to your backend, and do the vice versa on the response path. Then there's a question, if I already have traditional setup integration environment, converting them to REST as the first step would be get into digital world. Okay, so the first question, first part of that question is, would converting them to REST be the first step into getting into a digital world? So it's yes and a no. So it's not the fact that is it REST or SOAP is what's giving you the digital experience, but from my experience, like most modern clients, so what's closest to a user is basically the client that they use, which means it's a mobile device, it's a smartwatch or something like that. So most modern clients are capable of handling JSON and REST far better than handling SOAP. Therefore, it could be considered as an yes that making them REST would make them more digital, but it is not the only thing though. There are still some SOAP clients out there that work perfectly fine. Right. If my backend is already capable of handling conversion to REST and security and integration, do I really require a gateway just for analytics? Okay, so the question is, if the backend is already capable of handling the conversions, do I really need a gateway? So there are several advantages in using a gateway. So one is security, obviously, but in this case you have said the backend is capable of handling security, but still I would advise to go for a gateway, mainly because the security doesn't remain the same always. So there are newer trends coming up, there may be newer applications coming up that are consuming your services. Therefore, in order to cater those requirements, it's important that you have them exposed through a gateway, because these changes you can now do on the gateway without impacting your backend systems. Also, throttling and analytics is also some things provided by the gateway. And another thing is, so these if you have these exposed on the gateway, and when there are innovative ideas coming up to build newer applications, you could do the orchestration and choreography on the gateway itself without modifying your backend systems. So there are different kinds of advantages in proxying them through a gateway anyway, even if you don't have a value as of today, because it will definitely come in the future. So then there's a question, is Ballerina available with WSO2 or its future? So it's going to come in the future. So another question is, is the security, or rather the identity server, a mandatory requirement for the API manager? So no, it's not a mandatory requirement. The API manager alone can handle all of the OAuth related requirements. The identity server can come into the picture, for example, if you want federation kind of scenarios, like if you want to federate with a third-party identity system, with Facebook and other common identities, then the identity server would come into the picture, basically for advanced scenarios like that. But for the standard OAuth related stuff, the API manager can handle on its own very well. Okay, why use the API manager to authenticate and not identity server? Could you explain the benefits of this approach? So so there are different approach advantages. Like, you don't need a fully fledged identity server to just handle the API related security stuff like OAuth and the token lifecycle, the refreshing and all that. You don't basically need a fully fledged identity server in order to handle that. You only need the identity server if you want to go for advanced stuff like I mentioned before, like the federation, single sign-on, and those kinds of capabilities. So the identity server is like a bit more heavier than the API gateway, API manager itself, because it does a lot more things than just API security. Therefore, it's a bit more heavier. So therefore, if you do not need it, my advice would be to go with the API manager first. And if you in the future need further requirements, you could of course replace the security component of the API manager with an identity server, and that part can be done seamlessly since they are both WSO2 software. So you should start with the API manager only and move on if you need. So are the upcoming features available for preview in JIT? Some of it is. So so we have as of today we have done 2 milestones. So they are basically like very new. So the new API manager is undergoing lots of like architectural changes because there's lots of things we want to achieve, like lots of things we want to do in order to make it get down from like a 30-second startup time to a 2-second startup time and things like that. But yes, they are available in JIT. As of now, we are down 2 milestones, and we are continuing to do the rest. So what is the roadmap on Ballerina? That's another question. So the Ballerina is getting set up as a fully fledged integration language. So as of now, we are done version 0.8.085. So we hope to do version 1.0 in the time frame of June or so, if I remember correct, May-June time period, if I remember correct. So that is the plan basically. So again, Ballerina is like an open source project, and it's like on a separate GitHub repo and all. So you could contribute to it as well, and all of the development, including the roadmap, the documentation, the issues, and everything is on GitHub. So basically, if you go through that, you will get a clear idea of what's to come in the next version, such as like what's to come in version 09 and like that. But in general, that's the plan, to do 1.0 in the time frame of June or so, if I remember correct. And yeah, that will be a fully fledged integration language. Can you suggest few scenarios where gateway is required within enterprise boundary application, assuming having ESB already in place? If you already have the ESB in place, then the value addition of the gateway comes in the forms of security, rate limiting, and analytics, and the integration part goes away from the API gateway to the ESB. So the value addition here is basically the API gateway performs all API related meta like actions, whereas the ESB takes care of all the integration actions. So the benefit is you have architecturally you have a very clear and a clean separation in this particular instance. You can focus on the API manager to do simple pass through, and you can get your API layer to scale out separately and the ESB layer to scale out separately. And when it comes to upgrades and stuff, you can confidently upgrade the API layer because it will not affect your integrations. So those are some of the benefits in having an API layer, API gateway basically, when you have an ESB behind the scenes. What's your recommendation for short-lived services? Shall we do it on API Manager or use ESB as orchestration engine? So as of now, as of the versions released now, our recommendation is to do like API management, basically security rate limit and throttling on the API Manager, and perform integration on the ESB. So that is in the current versions. But if what you are talking about is like a microservices kind of architecture where your backends are microservices with one dedicated responsibility and stuff, then in the upcoming versions it's perfectly fine to do the integration on the API gateway itself. Mainly because like we are bringing in all the integration capabilities and all into the gateway through Ballerina. So that's in the future in the roadmap. But in the versions that are released so far, if you do have the ESB already in place, then it is a good thing to do the integration on the ESB and make the API Manager a clear API layer. If we need to support a REST call that responds with a stream of updates over a long period, is the gateway capable of handling this? Yes. Yes, it is. So we have tried out, for example, like the Twitter streaming API. I assume that's what you're referring to, something like that. So yes, the streaming APIs are supported through the API gateway. Can we do everything in Synapse mediators in Ballerina? Yes, that's the idea. So Ballerina again is like a complete integration language. So whatever the stuff that you could do in Synapse, you could basically do everything in Ballerina. So yeah, so as of now we are at version 0.85. So I'm not sure whether everything is available right now, but at 1.0 it will all be available. How can one access training for WSO2? So we do have some training material on site, and I believe there is a contact form that you can fill requesting for training. So we could get in, if you fill out that form and send us the details, fire us a mail on that, we could basically get you the information that you're required and conduct like even organized or customized training for you as well. Currently we are using the ESB. How is it different from the API gateway? So in the ESB, basically you don't get security rate limiting and stuff out of the box, and the kind of analytics that is done on the ESB is also like it's more of operational analytics only, not really giving you like business analytics. So the value addition of the API gateway comes in terms of like OAuth based security, rate limiting and analytics. So the API Manager gives you a way of defining your interface, and then it has a portal where your application developers could come in and discover your services. They could register their applications, and only allowed applications would be allowed to pass through. So that entire life cycle of API management, of exposing your services, getting onboarding your application developers, and then applying all the security and rate limiting to your request, that whole life cycle is taken up by the API layer. And ESB basically stays focused on the integration. So that's the main difference between the two. Do I really need the gateway for communicating within enterprise? or can it be done through the ESB only? So technically it can be done through the ESB only. Like I said, the value addition of the gateway comes in terms of security, rate limiting, and analytics mainly. Apart from the developer portal and all that. So that is the value addition that comes from the gateway. So I mean, technically within the enterprise boundary, you can do everything from the ESB, but I would suggest you to look at the value additions coming in from the gateway as well, because today you may call this as enterprise boundary, but you will not be limited to that in the future. So that is why this whole thing, that is basically what digital transformation is all about. You getting out of the enterprise boundaries and going out there into the world. Okay, so there's a compliment saying excellent webinar, guys. Thank you very much. Hope you enjoyed it. So there's a long question. Consider we have two external vendors who provide same service through SOAP. I need to configure both services in and expose as a single service from API Manager. From a user-defined application, which consumes this service, I will send a flag to switch services without changing code in consuming application. Is it possible to achieve this from API Manager? Okay, so I do not understand the question exactly, but what I think what you're asking is that you have two services back in the back end and you want to expose them as a single service from API Manager. So yes, that is definitely possible. You can call, so we call this like service chaining. We call both these services if required and give a consolidated response back by aggregating whatever the form that you ask it to. But you're also asking about setting a flag to switch between services. So yes, this I see as business logic anyway. So however the flag comes in, you can read it from the gateway and execute your logic in whatever the way that you can. Ballerina similar to Swagger, which current language? So Ballerina actually is very tightly married to Swagger. So Ballerina basically is both the interface and the implementation, and the interface is 100% compliant to Swagger. So Swagger only defines service interface. Swagger doesn't define what happens behind the interface. So Ballerina basically defines what happens behind the interface as well, but its interface part is 100% compliant with Swagger version 2 as of now. So if you have a Swagger file, you can auto-generate the Ballerina stub out of it, and if you have a Ballerina file, you can auto-generate the Swagger file out of it too, because they are very tightly married. Is there a limitation on the file size like 1 GB? So there is no limitation as I know. So you could transform larger files through the ESB as well. So do we have plans to support RAML? So we are not limited to Swagger, I mean like not restricted to Swagger as such as of now. But we haven't considered RAML in the short term future as well, because so it's a matter of which we decide to support. So at the moment, Swagger seems to be winning the race in terms of defining RESTful services. So what we think is like RAML is a bit off from Swagger. I mean, Swagger is a little bit ahead. So as of now, we've gone with Swagger. That's our choice, but that's not something that's set in stone. If definitely if RAML is making some head, we will consider including RAML as well. However, there are tools out there to convert from RAML to Swagger and Swagger to RAML as well. So if you have RAML files, you can basically convert it into a Swagger and get it imported on the API manager. Any performance recommendations tuning from WSO2? Yes. So in every release we do, we basically put out a performance document as well. So as you know, our products are free and open source. So all our releases happen like publicly. So in each release candidate mail we put out basically, which is again put to a public mailing list. We do release a performance document, and that particular performance document has the details of the performance numbers basically, and official documentation also has like details of performance tuning and things like that. So yes, you can find the details in the official documentation. Okay, so that seems to be it. Thanks guys for joining in, and hope it had been an informative session to you, and hope to see you next week on the Smart Analytics webinar as well. Thank you very much and have a nice day.